In this video, we're going to be going over the What is DNS. This is a section in the How the Web Works section of the pre-security path on TryHackMe. So what the heck is a DNS? And why is it that every time something goes offline like Facebook or Twitter, everyone says that it's the DNS's fault? Well, the DNS stands for Domain Name System. Think of it as a computer that stores name. Think of it as the internet's address book. It literally will point an IP address to a domain name. So let's take an arbitrary IP address of 111.111.111.111, whatever that's going to be, and let's say that that is abc.com. Well, instead of going to your web browser and typing in 111.111.111.111, you're going to type in abc.com because the DNS is what is going to know that abc.com is 111.111.111.111. Why did I make that my example IP address? I could have literally just used 11. So that is what this section is going over, is what is DNS. And here, of course, this graphic shows an example IP address for TryHackMe.com. So that's simple enough, right? Well, there are also more levels of DNS, believe it or not. In the next section, we go through the domain hierarchy and we see root domain, top level domains, and second level domains. And it will show examples of what each one of these domains are. For instance, you can see .com is like a normal privately owned company and .gov as any site that belongs to the US government. Other governments have websites on the internet. For instance, .ru belongs to Russia. .cn belongs to China. There's several others. There's a whole directory I'm sure you can find online, so check it out. So the top level domain will basically signify whether or not it is an enterprise or a government or an academic institution. Your second level domain will actually show the name of the organization itself. So for this example, we're looking at TryHackMe. So TryHackMe and TryHackMe.com would be the second level domain. And then for subdomains, we look at basically sites that exist within a specific domain. So for the example given here is admin.tryhackme.com, and that could be like an admin portal. Another could be shop.tryhackme.com. That could be a storefront. The more domains that you see on your browser, the more you'll start to recognize these pieces and kind of how many sites have individual subdomains that exist under the actual second level domain. DNSs collect records, and these are organized into several different kinds of records. For instance, an A record resolves the IP version 4 address. So you're probably more familiar with a record. A quadruple A or AAA record, I don't know if that's how you're supposed to say it. That record resolves for IPv6 domains. So that's probably something that we're all going to be seeing a lot more here in the very near future. CNAME records resolve to another domain name. So for instance, let's say TryHackMe.com would like to redirect to store.tryhackme.com or shops.tryhackme.com. That would use a CNAME record. MX records, mail exchange records, basically are for emails, and TXT or text records are basically for free text field. Now finally on this walkthrough, that takes us to making a request, and it shows you basically the steps of making a request, the different types of DNSs that you'll be in contact with. So first, you're going to try to see if you have any caches on your computer. So let's say whenever you're going to google.com, you'll type google.com into your browser, and then your computer will check and see if it has any cache, if it has any cached records to show the destination for google.com. If it doesn't, then it will forward to a recursive DNS. That's usually provided by your ISP. This also has a cache of locally stored and recently searched domain names, so it will check there as well. If that doesn't work, it will forward you on to a root DNS, and these are the backbone of the internet. That will refer you to the top level domain name, and then from there you'll be forwarded to the authoritative DNS server, which will actually return you google.com. So finally, to finish this walkthrough, I will leave the practical to you. There is a flag that you can get, and that is some good practice, and it basically will show you what all is going on with DNSs. But that is DNSs in detail. Very exciting. Pass. So what is HTTP? There is a 90% chance, that is a fake statistic, that you watching this video right now know exactly what HTTP is. But in case you have never interacted with the internet yet, there is a percentage chance that that has happened. HTTP stands for Hypertext Transfer Protocol. Now you want to be familiar with two different types of HTTP. There is HTTP, which is just that, it runs on port 80, and then there's HTTPS, which is HTTP, but the S stands for secure, and it is the encrypted, more secure version of HTTP, and that runs on port 443. Now there are several practical labs here along this walkthrough. You can do that on your own to be able to grab the flag for yourself. It is great practice and great visual representation of what's going on. But right now, let's jump into what exactly a URL is, which stands for Uniform Resource Locator. And here you have a nice graphic that breaks down URLs in depth. For instance, you have a scheme, you have the user, the host domain, the port, path, the query string, fragment. If you're brand new, this might seem a little overwhelming, but don't worry, it's fine. We're gonna look at this. Basically, the scheme shows the kind of protocol you're gonna use. So for instance, it could be HTTP, it could be HTTPS. You could use FTP for file transfer protocol. There's several other methods that you can use as well. The user, I feel like I haven't really seen this very often, seeing the username and password shown right there in the URL. So I think that this is kind of an older scheme. Maybe I'm wrong, let me know in the comments. But it could be theoretically in the name, and it would be username, password at, and then the actual domain itself, tryhackme.com. Now you'll see a colon and a port, and that is basically specifying to the destination that you are wanting to access via the specified port. So because we are using the scheme of HTTP, its default port is running on port 80. So logically, we will be reaching out to port 80. Now a path, we are trying to go to the path of view room. So we are looking for a room with an ID of 1. And that includes a fragment of task 3. So whenever you make a request using HTTP, basically you will specify your method, and that could be get or post. There's several other methods. We'll talk about all of that here in just a moment. Slash for the page, and then you'll do slash if you're doing the root page, or you can actually specify the page itself that you want to grab or whatever. Do any kind of request to. And then you will specify your HTTP protocol version. And then here we have down below an example of an HTTP request. You can catch all of this even in Burp Suite. If you are intercepting, or even if you're just passively watching web requests being performed, you can actually view all of this being done in Burp Suite. In fact, if you are intercepting HTTP records, and that traffic will be unencrypted, so not only can you view the traffic happening in Burp Suite, you can actually make different changes to it, and that can actually impact the user or the website, because now you are manipulating communication. That is called a man-in-the-middle attack. It's illegal if you don't have permission, so get permission or do it in home lab to yourself. Now, we were just talking about the different types of HTTP methods. So like, what are we talking about here? Well, these are just 4. There are several others out there, but the main ones that you want to be familiar with are get and post requests. Get requests basically are saying, hey server, get me this, and then post requests are saying, hey, I'm posting this to you. A put request updates information, and a delete request deletes information. But either one of those, you may see those much less often than you see get and post requests. Now on to the fun conversation of HTTP status codes. Who loves these? These are the best. Well, here we have a lot of the standard status codes, including we have basically the ranges. So 100 to 199 is informational or response. 200 to 299, it means it's some form of a success. For instance, 200 is okay. 300 to 399 is for redirection. 400 to 499 is client errors, and 500 to 599 is server errors. And if you're not familiar with what that means, you basically consider yourself to be the client and the server that you are connecting to be the server. So 400 is basically the web server saying, hey, it's your fault. 500 is saying, hey, it's my fault. And then of course, below that, we have the common HTTP status code. You'll probably encounter these at some point. In fact, error 404, page not found, that's it's got to be a meme on the internet at some point. So these will be good to be able to familiarize yourself with. However, I feel like, at least in my experience, whenever I see one of these codes, it will blast the message. So you won't just get 401. You might in some cases get that. You might have to do some Googling if you forgot, but it might also just say 401 not authorized right below that. So either way, keep these in mind. Now let's go to HTTP headers, because this is just so much fun. These are basically sent from the client, basically you, to the server. They'll basically show the host, so basically who you are. They will show the user agent, so basically your browser. The content length, so you know how much data that you are expecting, and accept encoding, whether or not you want to, you know, accept encoding. And a cookie. We will talk about that in the next section, so keep that in mind. Common response headers, set cookie, so that will actually set the cookie for you if that hasn't been been set yet. Cache control, which will store the content. Content type will tell you basically, you know, are you looking at HTML, CSS, a combination of these, and then content encoding. So those are some things to keep in mind. Now, mind you, all this is being done automatically on the back end. You're not manually doing this. Obviously, your browser and your computer are doing that with the server. But it's helpful, especially if you're wanting to get into cybersecurity or networking or what have you, to know about these things. Now, what are cookies? Nom nom nom. Cookies basically are unique to your session. They may include authentication data, so if you log into a service online, then your unique ID might be stored in some sort of an obfuscated form, hopefully in the cookie itself, and that basically lets the server know that you are you and you are coming from a specific session and you are authenticated. Your cookie will be unique to you and stored. So let's say you log into a website, then you leave, and then you come back the next day, you'll have the cookie and you'll be able to show the website, hey, it's me again, Hank the Cow Dog. And then you'll be able to continue to do whatever you're doing and it will remember you. Why does this matter? Because attackers might try to steal your cookies. No, not my cookies. And they will try to use that to imitate basically you to the web server and perform tasks as if they were you and steal data potentially. So protect your cookies with your life. If you want proof that you have cookies, check your browser. It has them somewhere. Now, to finish this room up, there's a making a request practical. There's several flags on here for you to get. Go ahead and jump through it. Super duper easy. You're gonna have a blast. It's just basically running through the different types of requests you can make to a web server. So with that, the next room will be how websites work. So how do websites work? Basically, you will make a request from your browser. That request will travel through the internet and it will hit the web server. The web server will respond to your request and deliver it to your browser and present it to you in a nice, neat fashion. For instance, whenever you decided to watch this video, your phone or browser, wherever you're watching this from, made a request across the internet to YouTube saying, hey, I want to watch this video, give it to me. And then it said, okay, bet, I'm gonna start streaming this video to you, so get ready for that. And then it started to do that, and well, here we go. Now there are two sides that we need to remember in this conversation, the client side and the server side. Consider yourself the client side. You are the client and the server is what's handling you. And the server is basically what has the website. They are providing the website and its contents to you. So how does it actually give this website to you? Well, the website is coded using HTML or hypertext markup language. It's really not hard to use HTML. I mean, you can see kind of an example down here. It's basically using logical sections and segments to create a web page. You can also use CSS and JavaScript to add functionality and neatness to the website. Pretty much every single website on the internet is a combination of these elements. So would it be helpful for you to know about how to use HTML? At least how to be able to read it? Yeah, that's not bad. And it's super easy, don't worry. If you'd like to see more, let me know in the comments. Same with CSS and JavaScript, because then you can actually manipulate with some of the functionality or some of the graphics. But you know, more on that at some point, I'm sure. Now a disclaimer, for pretty much every section on this walkthrough, there are some practical segments. So I encourage you to walk through this on your own and do some of those practical segments. I obviously have done them in a footage of that, but I just think that it's great practice for you to do that, especially on the sections where there are flags that are unique. You should definitely be doing that. Now let's talk about JavaScript. This is one of the most popular coding languages in the world, even though I hate JavaScript. This is basically used to control the functionality of the pages. For instance, if you're familiar with cross-site scripting, that's a type of attack that you can do on web pages. You're basically exploiting a logic flaw in JavaScript that the designers of the web page didn't account for. So like HTML, it is very helpful to be familiar with JavaScript and kind of how to recognize those things, especially whenever you're looking at the page source to see if you can break something. On the next section, we're looking at sensitive data exposure, and you can actually see that an example of sensitive data exposure, which is part of the OWASP top 10, there will be a video on that coming out at some point, but that's a big no-no. You definitely don't want to have sensitive information, sensitive personal identifiable information, any kind of details about your infrastructure. You don't want that hard-coded on your website. If you really need it on the web page, then you should retrieve it and not really show it anywhere in the hard code or in the code itself on the page source. Funny story, very true, very real from this last year. In the state of Missouri, a reporter actually noticed that there were sensitive information from teachers, including social security numbers, hard-coded like this and exposed on a website. They decided to report this to the school, and that allowed the school to be able to take that information down. However, the state government decided that that made that reporter a hacker. Even though they were taking the responsible step of notifying the school, hey, I noticed this, you need to take this down, this is very bad. And they did so, and it really helped, protect from a pretty bad goof up when building the web page. Now that reporter is getting punished. So definitely whenever you're putting these sites together, be very, very careful. The final section is on HTML injection. Basically, that's whenever you are inputting a malicious string into an input field, and it is either putting up some sort of malicious link on the site, it is rerouting the user to somewhere else. There are a number of things that you can do with this, but this includes a practical that you should definitely do. It's pretty fun. So the next section, we're going to put it all together. Now, we've learned quite a lot about how the web works. We've learned about DNS servers, we've learned about HTTP, we've learned about HTML and JavaScript and all those things. So let's actually piece it all together and see how it all works in a nice synchronous fashion to be able to bring you this video. As you can see in this graphic, you make a request in your browser that hits a DNS server. That DNS server will basically point to the web server that you want to connect to, and then the web server will respond and give you the content that you are requesting. There are several other components that go into this entire infrastructure, including load balancers. Now, YouTube doesn't just have one web server. That would be insane. YouTube had more likely, and this is probably the same with most companies that host anything, is they run with a series of load balancers, because the more requests that a web server gets, the more overwhelmed it becomes. And so you need load balancers to be able to help with that situation. Imagine you are self-employed and your company is expanding. There's only so much work that you individually can handle. So eventually, as your company grows, you hire somebody. Consider this similar to kind of how a load balancer works. As one server starts to get a little overwhelmed, some of that work gets pushed over to one of the load balancers, and it helps kind of keep everything nice and even and keeps the flow of traffic nice and smooth. Next, you'll have a content delivery network. And this is pure speculation, but this might be part of how YouTube works because it hosts all kinds of content like videos like this one. So whenever you want to watch this video, you'll ask YouTube, hey, I want to watch this video. And it will determine which server is closest to you that stores this video. It will route you to that server, and then that server will provide you the content. That way, that reduces the latency between the server and you. Next, you'll have databases, and these are basically storing massive amounts of information. I'm sure you know what databases are, but that's pretty much it. And then you'll also have web application firewalls, which add a layer of protection for the infrastructure as it is dealing heavily with the internet. You want to be able to filter a lot of that and prevent a lot of denial of service attacks and a lot of the malicious IPs that you see out there. So on this last section, we're looking at how web servers work. And if you've been watching along this series, then you probably know all about web servers because we've been talking about them the past several episodes. However, if you haven't seen those yet, definitely check them out. But what are the web servers? They are literally the server that is responding to your requests and getting you the information that you require. Some web servers run on what's called virtual hosts, and I've already have a video about virtualization. You can check it out right there. But I mean, it's a web server that is virtual. A lot of web servers run on containers. What's that? Check out containerization. There's links to those videos down in the description as well. You'll also have static and dynamic content. For instance, let's say you pull up a blog post. There's no videos, no graphics, nothing. It's literally just a document. That is static content. Nothing's changing. It's literally just the document. So you'll read the blog post and then that's it. But let's say this video. There's a lot going on. I mean, I'm moving around, I'm making noise. It's crazy up in here. This would be dynamic content. The web server will handle these kinds of content differently. Now, finally, there are scripting and backend languages like HTML, CSS, JavaScript. We've talked about those as well already. So finally, at the end, there's a practical exercise that includes a flag. You should definitely check this out and give it a shot. Grab the flag, and then let me know down in the comments section if you had a lot of fun. So next, we're gonna be going over Linux Fundamentals Part 1. If that's out already, check out the top video. If it's not, then you should catch up with the rest of this walkthrough and the playlist below. And as always, subscribe for more content because why not? I mean, it's free. Nothing's gonna happen. Nothing's gonna happen. Anyway, see you all next time.